Hello, everyone. My name is Hubert. I'm a CEO co-founder of vlayer. I'm very happy to be welcoming you and organizing this afternoon, almost afternoon today. We have a few items on our agenda, but we want to make sure that there will be enough time for you to chat with each other, mingle, and take the most out of this day. Very brief look at the agenda. I will start with a very brief talk. It's not going to be a lecture. It's just to balance the contents. Today, I wanted to go through a few use cases we are seeing with some of the teams that are already using vlayer for their projects. So it will be very application focused and hopefully to the point. Right after that, Arthur, our DevRel, will actually run a little workshop with an ambitious challenge to build a verifiable app within 20 minutes. So if you have your computers and you would like to follow along, Arthur will be joining the stage right after I'm done talking about applications. Then we'll have a very short break for you to replenish your energy levels, chat and mingle. And later we'll have two panels, not too long, 30 minutes. Some interesting topics from one side, talking about the community and what are some of the good practices around community building, and the second one will be more from the very pragmatic perspective of what investors have to say and how do they look at verifiable compute space, but also adjacent segments of the market. So two panels. And afterwards, we'll be inviting you for brunch and networking, which will take place downstairs. So relatively light agenda, and let me just dive in. So the intro, we decided to really focus on applications. We are relatively early stage, meaning that version 1 of vlayer has been released on mainnet. We are currently on EVM, on Ethereum mainnet, Optimism, and Base. Just 2 weeks ago, so it's relatively fresh, and we are collecting a lot of feedback what to improve. Nevertheless, we've been also working on some of the cooperations with projects that see value in utilizing our functions. So I just wanted to offer you a little summary of where do we see some of the emerging applications that seem to be useful. The first group is something that we call continuous proof of reserve. Proof of reserve is a financial term at the end of the day, and various industries interpret it slightly differently. So just to break it down pragmatically for you, we see two subtypes of use cases around continuous proof of reserve. The first one is called proof of asset holding. Effectively, it means that you want to, or someone wants to generate an attestation that they hold a particular asset. Importantly, it can be an on-chain asset, or it can be an off-chain asset. And now what we are seeing is that very interesting demand is coming from companies that are entering or utilizing digital assets, but they are developing some sort of permission systems for managing this. For instance, exchange-traded products is one category, and more of these companies that have legitimate volumes, have been around for a long time, they have a lot of users, are actually seeing more and more interest in digital assets, so they are including digital assets in their portfolios, but very often they are using institutional custodians, and it's not very easy to prove or to demonstrate to their end users and investors that actually digital assets that are supposed to be there are there at every single moment of time. So especially when there's a day where everything goes down by 20%, everyone is asking questions like what happens with this ETH or any other digital asset, and being able to generate these attestations in real time or very frequently, and being able to see them for yourselves is a value proposition that we see relevant. Importantly, proof of asset can work for physical assets, and we have an implementation for a gold tokenization protocol that uses an institutional custodian, a third-party company that is not necessarily a tech-savvy company, and they are specialized in storing gold, physical bars of gold in physical vaults, and they are great at doing this. They do it globally, but the best they can do is to send an email confirming that this serial number of a gold bar is actually sitting in a vault in Geneva, and this one is sitting in the vault in Heathrow Airport, and so on and so forth. So we are using email proofs, which is one of the features within vlayer to be able to generate these attestations directly from the email and being able to submit it on chain so that an individual user, individual investor of tokenized gold can see that there is the backing in real time. The second subgroup we are seeing is something that we call proof of asset transfer, because one thing is to statically have an asset, but the other one is to prove that actually a transaction happened. Here we see two main industries. The first one is called receivables finance. It's effectively getting money for the invoices that you are expecting to be paid for. And then there is a big problem of proving that actually the invoice is legitimate and that there is some financial history about this exchange. And very often there is a lot of manual process for making sure that you are financing a real activity. There is no fraud, there is no abuse in this flow. So we are working on generating attestations that a particular invoice was legitimately generated within some sort of ERP systems. Large companies typically use automated workflows for generating invoices, SAP being one of the big examples, and then you can prove that actually this particular document is coming from a legitimate source. And then the entire workflow for underwriting the invoice is much simpler and can be treated somewhat automatically. The last group is peer-to-peer transfers, which have been around for a while, and there we see more and more applications being built around this concept, and ZK-TLS, or web proofs as we call them, seem to be a great way of, first of all, confirming that a particular user has a particular bank account, and then being able to prove that a fiat transfer has really happened. And generating a web proof directly from their online banking app is a way for managing this escrow process for releasing the digital token that is being effectively transmitted. So continuous proof of reserve is a big umbrella term, but a few use cases where companies are actually seeing users and are using some of the verifiability tools in real life already. The second group of use cases, we call it proof of user activity, Web2 activity especially. And obviously there are a lot of things that you can do, but starting from the simple things is how to prove that you actually own a particular social media handle. So for instance, that on Twitter or X or any other social media platform, you are a particular digital persona that someone is claiming to be. And there are influencer marketing platforms, there are various actors that can benefit from the fact that they can verify that a particular digital persona logging in and claiming to be someone is really them. You can use traditional flow where you use APIs of some of these big platforms, but there are quite natural difficulties or limitations there. You are able to do this also in a privacy-preserving way. More interestingly, once we go the social media marketing path, is that you can think about very granular metrics that a creator can attest or generate attestation about directly from their device. So if I'm an influencer using Instagram, for instance, I would be able to, as a creator, access more data than is available via the typical API and generate attestation about who is following me, who is liking my post, and then submit this attestation directly to an influencer marketing platform out there. Thinking about loyalty systems, which is also a big use case because there's a lot of money flowing through loyalty systems, generating proofs that you purchased something online within an app or on some sort of website, or being able to prove that you purchased for a particular price. These are all quite useful use cases for loyalty systems out there. And then more just as a curiosity, there are certain competitions running online where proof of physical achievement, for instance, using Strava or Endomondo or other platforms like this, is also a very elegant, small application built upon web proofs in this case. And then obviously going to more financial use cases, very often there is a discussion around how can we incentivize users that seem to have particular history in terms of transacting when it comes to digital assets. generating an off-chain trade volume proof, for instance, based on Binance history, is a very, again, granular way of being able to attest that as a digital persona, you might be a valuable trader to a new platform that is willing to onboard you and maybe give you certain incentives to start with. The third group that is still being quite early, but we do see a huge future for that is something that we call streamlined onboarding. And in general, we see a world in which every user will be able to store and reuse attestations that describe their themselves, their identity, their activity, their assets, and they should be able to control and own this data and be able to share it only with institutions or companies or protocols that they wish to, and they should always be able to stay in control. We do believe that the KYC data is effectively a very great example. Like every time you are opening a bank account, you need to go through the same process. Why wouldn't you do it once and store the attestation about the underlying data? If we are using cryptography for that, why would you have to redo this every single time? Of course, there are certain regulatory restrictions. Certain KYC pieces of data need to be renewed once a year, once 5 years, depending on the use case. But there is certain stability to particular data that describe us as participants of a market. So why wouldn't you be able to utilize this? A very simple example that we are working on and implementing right now is a proof of active bank account ownership. So if I am able to generate a web proof directly on my native mobile banking app of Revolut, for instance, then it might be a sufficient enough token of trust that for a different financial application, I'm someone who has already undergone KYC. So maybe I can treat it as a light KYC token, and then only once I'm starting to transact within this new platform, I will have to redo the full KYC. But hopefully shortly we will be able to support a flow in which you generate, you conduct KYC flow directly from a certain application, and you are able to store that attestation on the underlying data within your self-custody vault, and then you are able to just use these attestations while you onboard to different platforms. This is exactly what I meant. Last comment, we do work on our builders program, and Namita here in the first row is the best person to talk about this. We have a few ideas how to make it easier for everyone out there to build by using vlayer. Of course, this is just verifiability is just one of the components you might need. Verifiable badges are live, so you can check them out, but we are working on grants, credits, and bank bounty, which should come soon enough. And we are also active during the upcoming hackathon, so hopefully if you will be spending your time there, you can think about using some of the tools that are available to you. A little bit longer than expected, but hopefully it was somewhat useful. Let's put it all in practice, and I would like to invite Artur to show us how to build a verifiable app in 20 minutes.
First question, who already tried some of the vlayer superpowers? Please raise your hand, because, okay, I see a few people. So maybe I will start with some explanation of what vlayer does and how it empowers Solidity developers. So as a Solidity developer, probably you already know that smart contracts are quite isolated. But thanks to the superpowers, now you can do more with your Solidity smart contracts. So first of all, thanks to vlayer, you have time travel, teleport, web, and email proofs. Time travel means that we can jump to the specific block number in the history, and we can read the balance from some smart contract from our DeFi positions and generate proof that can be verified in your smart contracts. Teleport is very similar to that, but we can not only jump to the specific block number, but also to the different chain. And finally, we have web and email proofs, which are basically bridges between Web 2 and Web 3 world. So for example, if you have some private data returned from some server that you trust, you can generate a proof out of it that can be used in your Solidity smart contracts. People often think about web proofs as oracles, but it's not the same thing, because oracles are perfect for public data. So if you would like to bring some data that is public, known to everybody, like the exchange rate from ETH to dollars is this, then you can use Oracle for that. But Oracle cannot help you with your private data. So it's very hard to ask oracles to know if you are above 18 years old, or if you own a Revolut account, or if you have a certain viewership on social media. It's not something available in the oracles, and web proofs can help you with that. And in the second, I will show you how you can add this to your projects, what are the steps, how to use it in the front-end side, how to use it in your Solidity smart contracts. I will get to that in the second. But last but not least, we have email proofs, which are very similar to web proofs, but here the source of the data is email message. So again, as long as we trust mail servers, then we can turn email messages into zero-knowledge proofs that can be verified on-chain, because every email is signed by the mail servers with the signatures that we can verify behind the scenes, just to be sure that you can extract the valid data. And I will also show you how this works. So you may be wondering how this is possible, how you can use that data in your smart contracts, how this works, right? So in vlayer, we introduced two types of Solidity smart contracts. We have prover and we have verifier. Both smart contracts, you can use Solidity. The only difference is that prover is executed in different environments. So we have a ZK EVM by vlayer that you can just run your code there, where the verifier smart contract is a regular Solidity smart contract that can live on Ethereum mainnet, Base, Sepolias, and so on. So, and the good thing is that in both smart contracts, you can just use Solidity. So you don't need to learn Rust, DSLs, some circuit language or whatever. You can still stay in Solidity with a bit of JavaScript. You can orchestrate it. I will show you how in a second. So let's start maybe with jumping into a bit of details what the prover is. So the prover is regular Solidity smart contract. It inherits from vlayer prover contract just to have some extra functionalities. That this is executed off-chain. This is maybe a bit, if people are hearing that for the first time, it's a bit weird, but I will show you in the second how this works. But long story short, it's executed in not public environments, so you don't have to worry about sending too much private inputs into the prover code, because it's not like public mempool that anybody can access. And of course, in the provers, we have some superpowers, like you can jump back in the history, or you can deal with the JSONs, or you can do regular expressions. These things are not normal thing in regular Solidity smart contracts, but in prover, you can use them because it's a different environment. You don't have to worry about gas fees and all the limitations that you have on the regular chain. And here's the example of our prover code. So if you are Solidity dev, you see some things that are familiar to you, right? We have require statement where we are checking something. If this check is not met, then we have some revert. But the new thing that probably you haven't seen before, it's the set chain ID. And this is the function in which we can provide, first of all, the chain ID to which we want to jump, and then we can provide the block number. And then once we call this function inside the prover, the next call that we have here to NFT smart contract, the owner of the certain NFT would be read from this specific point of time. So in regular Solidity, of course, we always have access to the latest data that we have on-chain, but here in the prover, we can set the context of our next calls to the specific chain and specific block number. And now I think it's worth to just say a few things about verifier. So it's, again, something that needs to inherit from our vlayer contract, because inside these contracts, we have only verified modifier, which makes sure that the proof that we passed into the verifier with some public inputs, which is, maybe I will go back because here you can see that we are returning the proof and some variable. Here it's owner. So this means that to verifier, we need to pass these two values. So it has to be a proper proof, of course, plus something that we returned from the prover. So this ape ID becomes private because it's not returned and it's not part of this proof for the verification. In the verifier, that we have only verified modifier, and this smart contract is regular Solidity smart contract. It's deployed to your desired blockchain. It can be Ethereum mainnet, Optimism, Base, some Sepoleas, and so on. And here we have two things that we need to pass. Of course, the proof plus the public input. And then we have only verified modifier, which makes sure that, first of all, the proof was created by the proper prover. So here we have a contract address, and this means that both prover and verifier has to be deployed to the very same chain, because we need to be sure that it's not a proof from completely different prover, right? Then, of course, we have to specify the selector of the function, which was used for producing the proof. And then finally, we have a body of our function that would be executed as long as the proof and the input are correct. Okay, so that's about introduction, just that you understand the concept of prover and verifier, because I know that in different products, in different libraries, sometimes these are different concepts. So I just wanted to be sure that you understand this execution model of vlayer. And now I will just I will jump into the code in the second, just to show you how to combine this all together and how to use it in your applications. But now just one example of each superpowers that just that you will see what you can do with it. So first we have the time travel. We can just call set block twice and just specify the block number ID. And then, of course, we can read a USDC balance in certain points of time. Of course, we can go deeper. We can have some for loops and check multiple balances in different block numbers. And for example, we can calculate the average balance of USDC. We can, of course, use it in different way, but it's just for you to see that it's regular Solidity. So you can just compose it however you want. Then the teleport is very similar, but here you can notice that we are not only jumping to the block numbers, but we are jumping also to the supported chains. So at the moment we are supporting Base, Optimism, and Ethereum mainnet, and Sepoleas for it. So these networks are supported. This is especially important for ETH Global hackers, because on this ETH Global there is a flow network that they also have bounties, but you cannot unfortunately use teleport and time travel with flow because we are not having indexers there yet, and we can only use it for web and email proofs. But of course, in upcoming months, we work on adding more and more networks. So here, for example, teleport, we can again do some cross-chain balance of something that is not feasible in regular Solidity smart contracts. And now a very interesting concept of the web proof. So let's say that we are building some real-world asset application. So always we have a problem that we can mint something on-chain, right? But the question is if there is anything in the real world that backs up my claim, right? Because I can issue a token that says like, okay, it's, I don't know, some gold or some asset tokenized, but always there is a question, okay, what's behind it? Is this guy telling the truth with this token, right? So what is interesting with web proofs is that, for example, we can have a call, we can have a request in our device, in the browser or in the mobile application soon, that I can go to my Revolut And based on the request to the Revolut, based on the response from the Revolut server, I'm able to generate a web proof. So basically, behind the scenes, our vlayer extension is looking on the TLS session. By the way, we are building that on top of TLS Notary. Great project. Maciej is here. He did a white paper on that. So also, I will show you if you would like to learn more. It's a great resource by Maciej available on our website if you are interested in all the internals. But long story short, WebProof is something that it notarizes the call between my device and Revolut server, and then enables me to prove that really this particular session happened and some data was returned from the Revolut servers, and then I can turn it into zero-knowledge proof that can be verified on-chain. So now I'm not only minting some tokens and then you have to trust me, but also I can enrich my smart contract that is responsible for minting some asset with some proof from some entity like Revolut or something else. So I think it's really important. Of course, I'm not saying that this is solving every problem and there are no scams from now on, but I'm just saying that it's great to have this extra trust that we can put in our smart contract. Another interesting example is all kind of Web 2 to Web 3 market applications. So web proofs can be used also if we would like to build a peer-to-peer decentralized exchange. So let's say I want to swap $200 to 200 USDC, right? So what I can do is I can use Revolut or some existing fintech application, and I can wire you $200 to some specific handle. Then I'm able to make a web proof that I'm showing, hey, I've sent $200 to some person that is part of this peer-to-peer marketplace. And then I'm able to turn this transaction into the web proof, send it to the Solidity smart contract that holds this USDC. And then the smart contract, when it receives the proper transaction with the proper handle that was sent to some guy on the Revolut, then the smart contract releases back the USDC dollars. So it's I think very interesting that we can compose web proofs with smart contracts and build all kind of interesting applications with that. So if you are interested now how this works in the code, right? Because I know that right now on the audience there are many hackers for upcoming ETH Global Prague. So you are probably very interested how you can use that in your project. So now let me switch to my editor. So we prepared for you all kind of templates. So each of the superpowers that I showed you has a dedicated template. So for example, here you can see the complete TypeScript code where you can see that, okay, first of all, we have to deploy vlayer contracts, right? You can do this locally. I'm running, for example, here on my machine, a local devnet for vlayer. So this is something that you can just try it now today. I just encourage you to do it maybe before ETH Global, because usually when all the people are starting using Docker in the same time, this can take a bit. But still, the devnet is something that you can just run with simple command on your machine. And then you are able to deploy the prover and verifier contracts. And now I think it's a good moment to just show you how this works, because vlayer is built on top of Foundry. So if you are familiar with Foundry, if you know how to build, deploy contracts with Foundry, I think it will be very easy to you. So here, for example, we have the prover contract, which is responsible for verifying my Twitter handle. So here inside this this contract, I can do all the superpowers that are not available in regular Solidity smart contracts. So for example, here I'm able to verify that web proof that is sent to the prover actually actually was generated out of the call to the api.x.com, right? So here is this endpoint. And here, please notice that this endpoint that I'm proving here, it's not a regular endpoint from developer API. It's just the internal endpoint for Twitter. So basically, I'm able to generate web proofs even from the stuff that is not officially released to the developers. So I think your imagination can started working now, that sometimes we have all these social media or some platforms that are not they're not sharing some official endpoints to do some stuff, right? It's hard to extract subscribers from Instagram, right? Because they of course want you to keep you on their platform, right? But now thanks to the web proofs, thanks to the TLS notary, you are able to notarize these calls even if they are not official APIs. And here, of course, you can do some assertions, right? So here the code is quite simple. I'm just getting the JSON, getting the string from the JSON, and I'm just proving that I'm owning a certain handle, right? But of course, here we can do some checks like, okay, if the followers are above 10K, or if I'm verified on the Twitter, then the proof should be valid, right? So you can here add some extra assertions. And then we have also verifier, right? The verifier is something that just takes the proof, takes the username and the wallet to which I would like to do some on-chain action, right? Here I'm just minting the NFT, but of course we can imagine a situation where the web proof is exchanged for something like there are, I think, many interesting use cases in the social media area where, for example, you can do the short where you are advertising some product, and then you can participate in some platform that if you are advertising their product and you have a confirmed 1K of views of your short, then it can be exchanged for some tokens, right? So I think there are many interesting ways how you can combine that. It's regular on-chain contract, so you can do some other checks here. You can send some ERC20. You can whitelist somebody, approve somebody to enter the DAO, or many other cases. So these are the smart contracts, right? And here maybe let's go back to this script that have the whole flow in it, right? So here I deployed prover and verifier. We are storing that in the .env file so our front-end application can access it. Here in this script, we are also simulating the rest of the process, right? So here we are creating a vlayer client, and then once we obtain the proof, which I will show you in a second how this works, once we have the proof, we can send it to the vlayer prover that can work either locally on our testnet. We are also available on mainnet. If you would like to go straight to the Ethereum mainnet, it's also possible now, and I will show you where you can learn about this. But here we can just pass this web proof JSON, and then we have to wait for the proof. And then once we have proof, then if you are familiar with WAGMI, if you are familiar with Web3 libraries, then you can notice here that it's stuff that you already know, right? It's no longer vlayer, right? It's if client, which is VEM in that case, or WAGMI on the front end. And then here you can, pass the proof, pass the Twitter handle, and then this is the code that is responsible for on-chain verification. So it's not something unusual, right? If you are building Web3 application, I think you will feel like home. So let's maybe now see how this works behind the scenes with the obtaining the proof. So here you can run this script locally, run proof dev. and it will just do exactly what I just explained to you. So deploy the contracts to the local Anvil blockchain. It will save that to your .env file, and then it will go to the prover and do the on-chain verification. However, also in the same repository, which is our template, you also have an example how this application works on the front end. So all I can do here is I can run, maybe I will switch to that mic, that would be clever. Here what I can do is ban run web dev. And here we are deploying our prover and verifier behind the scenes, and we are running just a regular React application. So if you are familiar with React, then you can see the whole flow of obtaining the proof. So here we'll try to get data from X. You can see that here I have my extension, right? So this is the vlayer extension. So for example, here you can specify like go to the X login page. And if we search for that inside our template, you will find exactly the place where you can specify this. So this is something that you are configuring on your front end, right? So in that example, we are doing something with api.x.com. So we are looking into that settings JSON. And we want to catch that web proof that would be exchanged for zero knowledge proof, right? So the reason why we are looking into that specific endpoint is that please notice that if I go here to the network tab, and I will just maybe refresh, we can see here, not sure if it's big enough, but you can see that this is internal communication between X and their internal APIs, right? So we have here api.x.com, and here what we can do is we can prove some certain things like screen name, right? That this is my Twitter handle, right? Of course, if you are interested in proving other stuff, you can just explore x.com and see other things that you can do here. Like it can be tweet body, it can be, amount of followers. And of course, the very same mechanism applies to other interesting applications. So the things that Hubert mentioned before, like if we are doing the proof of reserve, then probably you will go to Revolut or to some bank, and then you will look through these endpoints here. And as long as you can see the data and it's a JSON, then you can use the same technique as it is with this template. So if you would like to start building with that, I highly recommend you to just start with the templates. So go to our docs, it's book.vlayer.xyz. The installation part is very simple. You need to have Git Foundry in your system, then you have to run curl, and you will have a vlayer app installed in your system. And this is a command line tool that will always download the recent version of vlayer. And then in the first steps, you can see how to create a new project. And here we have all different templates. So for example, if you would like to build something with web proofs and it's a private data inside your browser, I will recommend you just to make a simple web proof. If you are proving something more backend where you don't need to have a cookie, when you don't need to have active session in your browser, then you can check our Kraken web proof example, which is basically notarizing the API call to Kraken exchange, and then you can extract from there some data and use it on-chain. If you would like to try teleport or time travel, we also have examples for that. So you can see the contracts, you can see the scripts, exactly the same flow as I showed you in the, just now. We don't have time to jump into each of these examples, but if it's something interesting to you, just fetch the example, see the code, and if you would have any questions, we are available on Discord, and also we have a dedicated support channel for the hackers that are at the EVE Global. So we will answer all your questions. So Yeah, another interesting concept that I would like to briefly mention to you is that web proofs also allow you to redact some sensitive information. So let's say that now Revolut server is returning here some JSON that is containing some sensitive information like my name, surname, and I don't know, my total balance, where I want to generate proof just that I have KYC in Revolut. And good thing is that we have also API for redacting headers and redacting body. So for example, if I'm getting the web proof locally on my machine that contains some sensitive information, then I'm able to hide it, to mask it, and then just push the web proof to the vlayer that is containing only information that I'm happy to share with vlayer, right? Because sometimes we might have some fields in our JSON that we don't want to share with anybody. So that's about web proof. And the last thing that I would like to tell you now is that please, there are a lot of the things that we didn't mention in that presentation. So vlayer job is that you don't have to learn exotic languages. You don't have to understand cryptography. You don't have to learn about circuits, guest IDs, DKIM records, storage proofs, and so on, because it's abstracted away from you by vlayer, right? So we want you to just use the stuff that you are already familiar with. So Foundry, Solidity, VM, WAGMI, all this TypeScript stuff. And you don't need to learn Rust or some other things. So other goodies, if you are, of course, interested in security assumptions and what we are using behind the scene, how it's possible that I can take a private web data and turn it into zero knowledge proof and it's secure, that it's not possible that I can have, spoofed communication with Revolut set up locally on my machine, right? It's all covered in our reports. If you are interested how email proofs are working in detail or on-chain proofs, it's all in our reports that are available on vlayer.xyz. Here's a great white paper by Maciej about TLS notary protocol. So if you are interested in all these details, we've got you covered. And yeah, I wish you happy coding with vlayer, ideally. And here is a link to our documentation. Thank you guys for your attention.